In the field of metal cutting manufacturing, the demands on quality and productivity are constantly increasing. Service providers have to deal more and more with highly individualized products, up to a quantity of one. This means a repeated high effort for production planning and setting up the machine with the appropriate clamping, elements and tools. At the same time, the requirements for documenting manufacturing quality are increasing. Especially in the aerospace, automotive and aviation sectors, these things are of outstanding importance. In the future, it will be necessary to develop and apply new methods of process evaluation and optimization. In particular, the use of real process data in combination with applications for the use of mathematical models and simulation approaches represent a promising approach. The interaction of the individual areas of data acquisition from machine and process, data management and application-specific applications leads to a continuous cyber-physical production system, CPPS for short. The following components are necessary for the use of a CPPS in machining. 1. The data source. This refers to the machine that performs the machining and generates the process data. 2. The interface for data acquisition, the corresponding interface to the data source. 3. A software system for data management. The acquired data must be managed and, if necessary, pre-processed and visualized in a suitable way. 4. The applications. These further process the data, generate new information and prepare it according to the objective. What are the advantages of using a CPPS system for the user? With the recorded process data, it is possible to generate a detailed image of the machining, a digital twin. Since this is based not only on the planning data but also on the data actually used, it is possible to derive comprehensive information about the process, such as dimensional accuracy, surface quality and energy consumption. Various approaches can be taken for data acquisition in the CPPS. It is possible to acquire the data via a software interface according to the OPC UA standard. Furthermore, additional sensors can be integrated into the machine. Another way is to integrate so-called edge devices from third-party suppliers into the machine. For the demonstrator presented for a CPPS, the focus was on the most widely used control in the machining sector, the C-numeric 840D. This means that the Simatic Edge, an edge device specially developed for use with C-numeric CNC, is used. The Detect IoT platform is used for data management. These processes are acquired process data in a suitable form, analyzes it using artificial intelligence methods and presents the results. Additional applications include a digital twin for evaluation, the digital process image, and a process monitor for monitoring parameters. The implementation of the CPPS as a mobile demonstrator, MCPPS, makes it possible to concentrate investments and learn about the advantage of using CPPS in machining. The demonstrator can be easily used on any machine with the necessary requirements. The use of a CPPS system is presented using the example of machining production. Based on the 2D and 3D design data, as well as the production planning data, machining is performed on a milling machine. All relevant data is collected, monitored and processed via the edge device. The result is a complete digital image of the process with additional information for evaluation, optimization and documentation. Would you like more information about the presented solution? Contact us. We are looking forward to hearing from you.